All right, we're going to go on now to Chapter 2, Test Form A, where we'll be getting some practice of what to do. Now, as we look at this, one of the things I should be mentioning is whenever you're working on math, and particularly a test or something serious, you need to consider your environment. Are you at a place where you can concentrate, not be distracted? Pencil, paper, eraser. If you're doing stuff at home, your calculator. Uh, and then as you are prepared mentally to do this, what are they asking you to do? Be sure you read the instructions carefully. Otherwise, you might think it says this, and that can happen to me, and I do it often. And not too often, no, but from time to time. Okay. So here what we're looking at, and even though chapter 2 is basically equations, we're not dealing with equations here, we're dealing with expressions. So the first thing they want us to do is to organize our data and simplify. That is, combine like terms. And if you recall from chapter 1, there were different methods. You could set them up vertically. In fact, I'm going to do it that way. I'm going to pick out my like terms, 6x, negative 3x underneath, and then a negative 8, and a plus 4. Now that I have them in like term columns, I'm just going to be able to combine them very well. This gives me a 3x here from this first column, and this will give me a negative 4. Now you probably could do that mentally too. Now for this one, you have a 6x and a negative 5.2x, and you have a 2 and a negative 7.3. So this is going to be a 0.8x, and we're going to subtract a 2 from a 7, and we get a negative 5.3. Now in number 3, what we need to do, and I'll clear that, is to get rid of the parentheses. So we're going to go 2x minus 6, distributing, plus 3x plus 12. Now, note, something like this, you may not have to set it up vertically. This is going to be a 5x plus 6. Now, for number 4, these were a little tricky in chapter 1, so let's take a look at it. Now, from this, they want us to subtract this. And in algebra, we do the subtraction by changing the signs and then adding. So this will become a positive 2x. This will become a negative 4. And now it's just a matter of collecting like terms. So we have 9x minus 7. Okay, again, we're doing some of that in a very easy way. Let's go on to start solving equations now, because that's mostly what we're going to do in chapter 2. Now, throughout all of these, we want to eventually get a 1x equals something, and we don't write the 1. So as we look at example 5, how do we get this x to be a 1x? Well, we're going to use our technique from chapter 1. We're going to divide by the numerical coefficient of x. So a -5 divided by a -5 makes it a +1. Now to keep the balance, we had to do something to one side. We must do it to the other side. And be careful about this because sometimes this is where a student will make an error that they'll forget to put the 5 there. I'm sorry, the negative in front of the 5. So this then becomes a +5. Now for number 6, again, we want to make that a 1x. Now, what technique do we know from chapter 1 to make this a 1? And the answer is, if we multiply something by its reciprocal, that product then is 1. And if we do something to one side, we must do that to the other side. Now here we can do some cross canceling. 2 will go into there once, 2 will go into there 9 times, and then here everything cancels out, and we're just left with a 1 everywhere. So this then becomes a 1x. We don't write the 1, but then on this side we go 9 times 3 is 27. Now for number 7, what we want to do is get all the x's on one side. And we want to try to keep our x's positive. That way we don't have to worry about dividing by a negative. So we had taught you the technique of taking a term from one side of the equation and transposing it to the other side. When we do so, the sign changes. So on this side it's a positive 5x. On this side it's a negative 5x. So then this just becomes an x equals a -3. And that's what we have for 6 here. Well, I guess we're on number 7 actually. How about for number 7? Okay, number 8 now. Notice they're getting a little more complex. But again, we still want to get all of our x's on one side and try to keep them positive. So I'm going to take this, move it to that side. When I do, it becomes a -6x. So we're just left with an x on this side. And I should have combined this before. This becomes a 5. When I move it to this side, it becomes a -5. And I didn't show all of the steps here, but the process. I'll write this one out fully. So the first thing, clear the parentheses. So we get -2x, -6. 3x, -21. And we want to keep our x's positive, so we're going to move this to the other side. On this side it becomes a 2x, so that'll give me a 5x. This, when I transpose it, becomes a +21. Subtract 6 gives me a +15. Now to get rid of the 5 that's with an x, I'm going to use its numerical coefficient, divide both sides by that, And then for number 9, I get x equals 3. Okay. Let's move it up a little. Because now we're getting to that other kind of equation in which there are fractions. So the technique we said to use here is to multiply each term in your equation by the lowest common denominator of your fractions, which happen to be 6. So this is one term, this is another, this is another. And by the way, what I could have done here is just add these two together and get 4x. That would be good. But just leaving it the way it is, getting rid of all the fractions. And then here, I'm going to multiply this by 6 also. Now I do my canceling. 3 goes into there once, 3 goes into there twice. Nothing there, nothing there. 2 goes into there once, 2 goes into there 3 times. Now, I have a new equation. It's not the same, but it's equivalent, and it doesn't have any fractions. So now I'm going to go 2 times 2. That's 4. I didn't write too well there. And then I have a negative 6x. This is going to be a positive 30x. And this is going to be a 3x. Now I have 4, and I'm subtracting 6x from 30x and getting a positive 24x equals 3x. I'm going to bring this now, well, I'm going to bring this over to this side. I'm going to keep my x's positive. Transpose the 4, that becomes a negative 4. So then I get for this, x, when I divide both sides by 21, this will be number 10. X equals a negative 4/21. Okay. Ten doesn't have this type of fractions, but has a decimal fraction, which we also want to get rid of. So we'll multiply that by 10, multiply that by 10, just move the decimal place over. And this we have to put an extra point in there, multiply that by 10. So this is now a negative 2 times 3x minus 8 . We had an incoming phone call there. So let's check this out again. We're going to multiply every term by 10 to get rid of all the decimals. Now, once again, it's not the same equation anymore, but it's an equivalent equation, and the x has the same value. But it's easier to work now without the decimals. So we're going to distribute and get a negative 6x, a positive 16 equals 16 plus 20x. And let's make this a nice plus sign here. An interesting thing happens. When we subtract 16 from both sides, these cancel out. And when I transpose this to the other side, it becomes a positive 26x equals 0. And now when I divide both sides by 26, I get x equals 0. And that is a good number. X equals 0 is the answer. And if you put a 0 where the x's are, this checks out very well. Okay? Now, let's go on to our next one where we still have to clear parentheses. And let's see what we get. I'll write it up here. So 3x minus 15 equals 2x plus 10 plus x. Group like terms, I get 3x minus 15 equals 3x plus 10. When I subtract 3x from both sides now, the x's disappear, and I'm left with a negative 15 equals 10. Is this a true statement? No. When you get something like this, even though it looked like an equation, because the x's cancel out, for number 12, there is no solution. We can write that as an empty set or as a null set. All right, let's go on to 13. Here, this is going to be 12 minus 24x, and this is going to equal a negative 2x minus 10. Now, to keep my x's positive, I worked a little bit here to show you transposing as needed. And I get x is going to be what here? When I divide both sides by 22, x equals 1. Okay, I'm going to make this tape into two parts. This would be the working of the equations. And if that's all you need, you can watch just this part. If you need the other part, I will do these word problems. There's 11 of them coming up.